Okay, moving right along. So here, if you notice, you don't have a log. Or I'm sorry, you don't have a constant. You have one log here, one log here. They have the same base. We didn't quite have a problem like this because I want to move the 2 over here, but I can't just take that 12 and turn it into a 6. The idea is first, I'm just going to rewrite this as, well, like that. I'm not really writing it, am I? So the idea is I'm going to actually bring this back as a squared. And the idea is when you square a square root, they cancel out. So over here, I'm actually just left with x. And now that I have one log here, one log there, no constant, and they have the same base, it's that unseen 10, I can ignore that and I get my answer. My answer is just 12. Okay? Next one. Here, let's see. We're going to look at this x as a constant. So what we're going to do is go over here, and before I can turn this into an exponent, because it's a log problem, we're going to condense the logs down. So if you ignore the logs and you look at this as 56 minus 7, you're going to turn it into 56 divided by 7, which is just 8. And then you can bring this log 32 back, and now you can solve the problem. So 32 to the what power gives you 8. This is definitely a tougher problem. So this is going back to, you got to think of those exponents. What would be that common base? And a common base between 8 and 32 is 2. So 8 can be turned into 2 to the third, and 32 can be turned into 2 to the fifth with the original x that's there. Now that those bases are the same, you can ignore them, and you get 5x equals 3. So x equals 3/5. So this is definitely a problem that we did not see. So I would not plan on one here like this on the test. So just know that. Good practice though. All right, moving along. So this is an exponent problem that has a constant. So we're going to be turning it into a log, but I can't turn it into a log until it's just this base and this exponent. So I'm going to move the 5 and the 18. And the first thing I'm going to do, I'm going to put a 1 here, is I'm going to add 18. And now to move the 5, I'm going to divide by 5. And that gives me a pretty good number. And now I'm ready to make my L. So again, that big L that you just wrote is your key to write log. But log E is just ln. So I'm just going to go straight to ln of 43.6 equals negative 1x. So anyone can just type in natural log of 43.6. You get this decimal. And now to get x by itself, just divide by negative 1. So your answer is a negative version of that. All right, next one. So on this one, I have a base and an exponent. There is a constant, so I'll be making my L, but I can't make my L until it's just this, so I'm going to divide by 3. So if you take 2352 and you divide it by 3, you get this. So 4 to the what power gives me 784? I don't know. So we're going to turn it into our log. So log 4, 784. And again, some of you can just type that in. The rest we're going to do this. So if you log of 784 and divide it by log of 4, you get this answer for x. X is 4.807. All right, next one. So here I have a constant, so I'll be making this log into an exponent, but I can't do that until it's one log. So we're going to go back to the condensing, this first couple problems, and I'm going to ignore these logs, and I'm going to look as x plus 5 plus x, and I'm going to turn this plus, not this, because this is part of the log, into times. And I'm just going to distribute the x into x and the x into 5. And now I'm going to bring the log back, and then the 2. So now I'm going to make my e. 6 to the second power equals all of that. And 6 to the second power is 36. We are seeing more than one x. You will have a problem like this on the test. There will be one that you factor. So I'm going to bring the 36 over. If you don't want to factor, you can always do the quadratic formula. A is 1, B is 5, C is negative 36. But otherwise, if you multiply, you're going to get negative 36x squared here. Whoops. And 5x here. And then your factors are going to be 9 and 4, with the 4 being negative. So now I'm going to rewrite it, but instead of 5x, I want this 5x. So again, it's just x squared. There's 5x. There's minus 36. You're going to group them, or top row of your box and bottom row of your box. And out of this, I can factor out an x. And then x times what is x squared? That's the x. And x times what gives you the 9x? That's 9. So that means this has to be x plus 9. And that means what in front here times x gives you the negative 4x. That's negative 4. And really squishing this in there. So now my two parentheses are x plus 9 and x minus 4. And my two answers are what makes these 0. So negative 9 and 4. All right, next problem. So on this one, I see logs. I don't see a constant. I don't need to make an e. And there's just one log here and one log here. The only problem is this 1/4 is not a constant. So I'm not going to, be doing the e. I'm just going to move this back as an exponent. And again, we didn't see a problem like this on our review, or I'm sorry, on our stuff. So 81 to the 1/4 power, that's like the 4th root of 81. And the 4th root of 81 is just 3. So now if you just ignore the logs, you're going to see that x is 3. All right, almost done with solving. So again, I am looking at this problem. And I'll be honest, I'm not quite sure. This review was borrowed from somebody else. These, I can't have x and y. So you know what we're going to do is let's change. There should be numbers here. So let's just change the numbers, the y's. So sorry about that. I didn't realize that. So let's change this y into a, let me think of a number. Let's turn this into a 26. Okay, so there is a log, and there's a constant here and here, and that means I'm going to be making my e, but I'm not going to make my e until the 3 and the 5 are over. So first I'm going to subtract the 5, and I'm going to switch it to being over here. So subtract the 5, that's 21. I'm going to move the 3 by dividing it. So that gives me 7. And now I'm ready to do my e. Let's put our base, so e to the 7th power equals all of that. And then you can go to your calculator, figure out what e to the 7th power is. It's this. And now to get x by itself, just add 1. So your answer is 1097, and then your decimal. And let's go ahead and do the same for the next one. Let's just turn this y. I'll just turn it into a, let's turn it into a 10. Okay, so there is a constant here and here. We're going to get just the base, which is ln x, and we're going to move the negative, which is like a negative 1 there, and the 25. So first I'm going to subtract 25. I'm going to put it on this side now, and that turns that into negative 15. I'm going to divide by negative 1. And now I'm going to make my, my e. So there's the base. So e to the 15th power equals x. So whatever e to the 15th power is, that's x. And I'm not going to type that one because I just think that's going to be a slightly bigger number than we're used to, but e to the 15th power. Okay?